This video is a short tutorial of the Safer Places' cloud web platform. The platform is available online as beta version at the following web address: platform.saferplaces.co. This video tutorial describes the main characteristics of the platform and how easy and fast is running a tailored flood hazard and damage assessment simulation, and inspect the final results. Safer Places platform provides a cost-effective and easy-to-use cloud web service for mapping flood hazards and economical damages related to actual and future climate scenarios in our cities. Safer Places platform can support multiple stakeholders and end users in designing flood climate resilient cities through the simulations of multiple mitigation and adaptation projects and scenarios. The intelligence behind the Safer Places platform integrates innovative FastDem-based flood hazard and Bayesian damage assessment models able to provide results in real time, exploiting the power of cloud computing. A first beta version of platform is available and so far is active in 4 pilot cities: Rimini and Milan in Italy, Pamplona in Spain, and Cologne in Germany. The cloud web platform doesn't require any software installation on the user's PC, and it just requires a web browser. After the selection of one of the 4 cities available, in this case we select the city of Rimini, the user should proceed through the login request, inserting name and email address in proper fields. The registration procedure generates automatically the new credential communicated via email. The user's credentials can be used for the login and finally give full access to the platform. The web application is composed by several task panes located on the left and a web mapping environment in the right. On the left, the user can click and activate different panels. Starting from the bottom, the layer pane displays the list of spatial layer generated by the platform and a set of preloaded data such as different backgrounds such as Google Satellite or OpenStreetMaps, the litter of the study area, and the polygon of the buildings. The group of layers named as river, rain, coast are initially empty and will be populated later by the output generated by the simulations. The first task pane, source scenarios, is dedicated to define multiple flood hazard scenarios related to pluvial, fluvial, and coastal events. The user is free to generate whatever flood hazard scenarios specific for the city of interest, representative for historical or climate projection conditions. In particular, the user can set up a tailored and specific rainfall events characterized, for example, by a specific rainfall intensity in and duration in hours. The checkbox INF is related to the possibility of activating the natural green AMPT infiltration model. For fluvial events, the user can select a list of preloaded flood hazard reference maps to be used as benchmark for the GFI calibration and the generation of a flood hazard maps at higher resolution. For coastal scenarios, the user can set up multiple extreme sea level in to be used in coastal flooding simulations. For the city of Rimini, we generate 3 different flood scenarios. The first is a rainfall event with return time of 100 year, characterized by a duration of 3H and intensity of 95 mm. For this scenario, we activate the natural infiltration model. The second scenario is related to river flooding, and we simulate an event of 100 years return time. The last scenario is generated by coastal flooding and characterized by a return time 100 year with climate projection RCP 4.5 for year 2100. The extreme sea level is equal to 2.77 meters. Clicking in the ADD checkbox, the user can submit the generated flood hazard scenarios to the control panel for the process execution. But before submitting to execution, the user should also check and modify the hazard and damage parameters through the specific panels. In the hazard scenario task pane, the user can select different city orography representative, for example, of mitigation scenarios for the city. In the case of Rimini, the user can select the litter representative of the Parco del Mare implementation, a new sea promenade project where a dedicated physical barrier is implemented for coastal risk mitigation along the sea promenade. In the next version of the platform, a specific web tool will give the possibility to the user to design and insert mitigation measures, such as barriers, directly in the platform. The damage model task pane, the user can select and apply a specific set of damage mitigation measures to the building. In the current version, the damage assessment calculation is performed without considering the mitigation measures. The other task pane, dashboard and risk, are still in development and basically will provide the possibility to compute expected annual risk in case of multiple scenarios with different return time, while the dashboard will summarize and plot indicator of the hazard and damage calculations. Coming back to the source scenario task pane, the user can finally submit the generated flood scenarios to the control panel for running the simulation. The submission of generated scenarios is done just clicking the Add checkbox. The user can run all the process clicking over the dedicated button, or just activating a single simulation. The single process starts and the user can follow the stage of processing. After few minutes, the user can display the first results related to water depth and damage assessment of the scenarios. The water depth and economic damages layers are generated and uploaded in the specific layer group available for rainfall, coastal and river sources. Through the Identify button, the user can inspect the water depth value pixel by pixel or the economic damage building by building. Finally, the user can download the generated output as GeoTIFF files just with right-click over the layer of interest. Thanks for your attention and follow us.